Sometimes it's a good idea to package neighborhoods of collaborating objects together inside of a component for redistribution or for sharing. So a component is simply just a reusable package of objects that we've defined. Now, in different programming languages and operating systems and frameworks, this will take different forms. In the .NET world, this usually takes the form of a class library. So you have the class library project. You know that when you compile a class library project, it's going to create a .NET assembly. Typically, that .NET assembly will have a .dll file extension. Inside of that assembly, we have a number of classes we defined, a neighborhood of classes that all kind of contribute to do something meaningful. I gave you the example of Newtonsoft's JSON.NET in the previous video. That would be a great example of functionality of classes that were compiled together into a component for redistribution. So you also get, in the .NET world, the convenience of NuGet for distribution from a centralized repository, version and dependency management, and so on. Not going to talk about that now. But at any rate, reuse is one of the benefits of object-oriented programming. Now, I said earlier, this used to be considered the holy grail of object-oriented programming. Hey, we write it once, we'll never have to write it again. Look, management, this is going to be the solution for all of our problems. We can save money and only have to write code one time. And, you know, at first, people didn't really understand the implications and the requirements it took to really make reuse a reality. And it took time and a lot of failures. That's why we have principles that we have today, because a lot of lessons were learned in that time. But it no longer was the holy grail. It kind of became something that everybody said was impossible to achieve in reality. So the reusability dream didn't really materialize the way that some of the original people who were proponents of this notion would have liked, but people began to wonder if reusability was even possible, or do we have to rewrite this functionality every time? It is possible, but you have to clearly define your neighborhoods. One of the things that I learned from playing the game SimCity, have you ever played that game? It's awesome. I've wasted so many hours on that game. One of the things that I've learned that I didn't know prior to playing SimCity was that there are parcels of land that cities will designate into commercial areas, residential areas, industrial areas, and agricultural areas. And as you get further into the game, these become even more specialized with high density and lower density, and so on. And so the practicality of this means that, you know, you'd have to really work hard to put a factory next to somebody's $1 million mansion in the game, right? Or even in real life, you don't see somebody moving in your neighborhood, at least not where I live. You can't just start a business in the middle of a neighborhood. That the city would be shutting that down, right? So the same is true with neighborhoods of objects. Objects should stay in their neighborhood based on their zoning or their purpose. Now, in practical terms, I suppose it means, first of all, that ideally components should contain either domain-specific objects or application-specific objects, but probably not both. When you're mixing that boundary, then you are definitely overstepping two zones. Second implication is that I think ideally components should be narrowly focused on a very specific task. So I think you should be able to state that task without using the word "and" as a conjunction. So, for example, the creator of JSON.NET did not say the JSON.NET component can parse JSON and persist it to SQL Server. The "and" persist to SQL Server part would be problematic, right? Why don't we just leave that to somebody else to handle, like the Entity Framework or perhaps another library, okay? So it should be very narrowly focused, that neighborhood should be. And then the third thing to consider is that ideally components should define interfaces that allow its dependencies to be sent or delivered or injected into it. So this will require some explanation, dependency injection and inversion of control. That's the principles that are super important, but I want to hold off on those thoughts. They're a little bit more advanced from where we're at right now. So hang on to it, we're getting there. And then the fourth observation along these lines is that ideally components should be composed of neighborhoods of objects that are engaged in similar work or have similar end goals. So if a large application will touch many different facets of a business, including accounting and retail and membership and marketing and inventory and other domain related tasks, then the domain objects that are required to implement the business rules and the data structures should be grouped together logically into individual neighborhoods, one for accounting, one for retail, one for inventory, and so on. So how do you do this? Well, these sorts of things, these neighborhood associations, these zoning laws, I guess you could say, will begin to reveal themselves when we begin to look at the types of messages that are going to be exchanged between objects. In other words, there will be some natural, organic segregation of components based on their common goals. Now, I just want to state this because we live in a world of diversity, and this is not an attempt to comment on the reality of the world. Whether we have diversity or there's a lack of diversity. It's just plainly stating that when it comes to objects, the idiom birds of a feather flock together should be observed and should be honored whenever we're thinking about packaging classes, objects into their own neighborhoods for reuse. So not only does this keep collaborating objects in their own neighborhoods and help reusability, but it's also a mechanism that can be used for human collaboration. So when we divide up the object definitions, the classes, into smaller components based on their neighborhood, whether they're domain or application specific, if they are a domain object, are they dealing with accounting or retail or inventory, then it makes it easy for multiple developers or even multiple teams within the same organization to work on the project as a whole at the same time, with everybody focusing on some part of the entire project instead of everybody kind of scattered and working on various parts all at the same time. So one team defines a component and its interfaces, and the other team that will consume that component, even if it's not ready to be used just yet, it's under active development. Perhaps at the very least, there is a contract, a set of interfaces in place that the consuming team, can at least work against in the meantime using a stubbed out object that implements the interface, and work can continue in parallel. Now, this is something that's very difficult to do in a procedural or monolithic style of programming. This is one of the things that makes object-oriented programming so appealing, is the ability to divide up a large piece of work and conquer it with several different members or teams. And it's all possible whenever we are planning ahead of time and designing our objects and putting them in their natural neighborhoods, and then repackaging those neighborhoods into components for reusability. Okay, so let's continue on the next video. Thanks.